The 787 electrical system generates, distributes, and manages airplane electrical power. System operation is automatic. In addition to traditional electrically powered systems, the 787 electrical system powers engine start, pressurization, wing ice protection, stabilizer trim, 2 pairs of spoilers, and wheel brake systems. The system primarily uses 115-volt AC and 28-volt DC power, with a limited number of systems optimized with 235-volt AC power. Controls for the electrical system are located on the overhead panel. Review the electrical panel controls before pressing the Continue button to resume the lesson. Electrical indications are displayed on the electrical synoptic page on the MFD. Review the indications before pressing the Continue button to resume the lesson. The electrical power sources include 4 variable frequency engine starter generators, 2 variable frequency APU starter generators, 3 external AC power receptacles, 1 ram air turbine, 1 main battery, 1 APU battery, 3 flight control permanent magnet generators, and 2 EEC permanent magnet alternators. The power sources remain isolated from each other throughout the generation and distribution channels. During power transfers, a brief power interruption may occur as buses are energized from a new power source. The engine starter generators function as electrically powered starter motors for engine start and as engine-driven generators once the engines are running. Each engine has 2 235-volt AC variable frequency starter generators. They are directly connected to the engine gearboxes, producing variable frequency power proportional to engine rotor speed. The starter generators are designated L1, L2, R1, and R2. During start, the electrical system automatically selects both starter generators to engage in order to provide optimal torque for engine start. After start, the starter generators function as generators to energize their respective main AC buses. The AC buses are also designated L1, L2, R1, and R2. Generator status is displayed through generator switch indications, the MFD electrical synoptic, and ICAS messages. Each generator also has a drive disconnect mechanism that allows the generator to be mechanically disconnected from the engine. Depending on the fault condition, the generator drive is either automatically disconnected or will require crew action to be disconnected. When a condition is detected that requires the flight crew to disconnect the generator drive light illuminates, the generator drive indication displays on the synoptic, and the ICAS advisory message, Electric Generator Drive, displays. The generator can be disconnected from the engine by pushing the respective generator drive disconnect switch. Once disconnected, the drive cannot be reconnected by the flight crew. The APU starter generators function as electrically powered starter motors for APU start and as generators once the APU is running. The APU generators can provide electrical power for ground operations and supplemental power during flight. The APU has two 235-volt AC variable frequency starter generators, designated left and right. The generators are directly connected to the APU gearbox, producing variable frequency power proportional to APU speed. The electrical system automatically selects a single starter generator which provides sufficient torque for APU start. The left or right starter generator is used for APU start if an engine is running or forward external power is selected on. For APU starts with the APU battery as the power source, the right starter generator is always used. On the ground, both APU generators are available to energize the airplane's 235-volt AC electrical buses. In flight, one or both APU generators provide power, depending on the electrical load requirements of the airplane. Generator status is displayed through generator switch indications, the MFD electrical synoptic, and ICAS messages. The 115-volt AC external power system consists of both a forward and aft system. The forward system provides the power for general ground operations. It has two power receptacles located on the left forward fuselage of the airplane. Connecting one or both power sources to the receptacles illuminates the available lights on the appropriate external power switch on the electrical panel. Connecting a power source will also energize the ground handling mode. Only one connection is required to power this mode. If two sources are connected, the first source connected is the one that is used. Selecting the external power switches to on energizes the external power on mode and extinguishes the available lights. Two connections are recommended in this mode to power the maximum number of electrical loads and minimize load shedding. The aft external power system is used to assist the forward system when both forward connections are available, the APU is not available, and starting the right engine first. The aft receptacle is located on the airplane fuselage aft of the left wing. The ram air turbine, or RAT, serves as an emergency source of electrical and hydraulic power. The RAT has no operating time, airspeed, or altitude limitations. In flight, the RAT deploys automatically if any of the following occur. Both engines have failed. All three hydraulic system pressures are low. The loss of all electrical power to the captain's and first officer's flight instruments. The loss of all 4 electric motor pumps or EMPs, and a fault occurs in the flight control system on approach. Or the loss of all 4 EMPs and an engine failure on takeoff or landing. The RAT can be deployed manually by pushing the ram air turbine switch on the hydraulic panel. The airplane has 2 primary batteries, the main battery and the APU battery. The main battery power switch is located on the overhead electrical panel. The APU battery functions automatically and has no power switch. Operating indications for the main and APU batteries are provided on the electrical synoptic. The main battery provides power for airplane power-up, APU start, refueling operations, towing operations, electric braking, and captain's flight instruments. The APU battery provides power on the ground for APU start and navigation lights. 3 engine-driven permanent magnet generators, or PMGs, are the primary source of power for the flight control electronics. PMGs are independent from each other and from the main airplane electrical system. A secondary source for flight control power is provided by the airplane's 28-volt DC bus distribution system. An additional backup system is provided by dedicated batteries, assuring positive flight control operation during temporary power interruptions. 2 engine-driven permanent magnet alternators, or PMAs, are the primary source of power for the electronic engine control, or EEC. PMAs are independent from each other and from the main airplane electrical system. A secondary source for EEC power is provided by the airplane's 115-volt AC bus distribution system. During engine start, initial EEC power is provided by the 115-volt AC bus until the PMAs are able to provide power. Once the PMAs are operational, the 115-volt AC bus serves as a backup EEC power source if the PMAs become inoperative. The electrical system uses 2 distinct power distribution methods, primary and remote. The primary power distribution method energizes higher amperage loads directly from bus power panels located in the forward and aft E&E bays. The remote distribution method energizes lower amperage loads through a decentralized network of 17 remote power distribution units, or RPDUs, located throughout the airplane. The majority of airplane electrical loads are 115-volt AC and 28-volt DC, energized by the forward E&E bay power panels and RPDUs. However, a limited number of high-voltage 235-volt AC electrical loads are energized from the aft E&E bay. The E&E bays also contain power conversion devices, which change power from one voltage or current type to another, and system controllers that direct power to the various airplane buses and systems. There are 4 main 235-volt AC buses, designated L1, L2, R1, and R2. These primary power system buses are located in the aft E&E bay. The buses distribute power to a limited number of high-voltage AC systems and all other aircraft bus systems through power conversion devices. The 235-volt AC buses can be energized by several different sources, depending on availability and operating configuration. On the ground, with forward external power selected on and no engine or APU generator power, the 235-volt AC buses are energized by the 115-volt AC distribution system through power conversion devices. If the APU or an engine is subsequently started, it energizes the four main 235-volt AC buses, and external power transitions from on to available. On the ground, with only the APU power available and no external power or engine generator power, each APU generator energizes two of the four main 235-volt AC buses. With one engine running and no APU or external power, the operating engine's two related 235-volt AC buses are energized directly. The other two 235-volt AC buses are then energized by the two powered buses. With one engine and the APU running, the operating engine's two related 235-volt AC buses are energized directly. The other two 235-volt AC buses are energized by the APU generators. With both engines running, each main 235-volt AC bus is energized directly from its related engine generator. If any engine generator is not available, its related main bus is energized by another main 235-volt AC bus. Operating conditions for the 235-volt AC system are displayed on the electrical synoptic. Additionally, the ICAS caution message, electrical AC bus L1, L2, R1, or R2 is displayed when a main 235-volt AC bus is inoperative. The 115-volt AC system uses multiple 115-volt AC buses to distribute power. The 115-volt AC buses consist of primary power system buses located in the forward E&E bay, and RPDUs located throughout the airplane. The higher amperage loads are distributed directly by the bus system. The lower amperage loads are distributed by the RPDUs. On the ground, with the forward external power selected on and no engine or APU generator power, the 115-volt AC system is energized directly from external power. In this state, the 115-volt AC system energizes the 235-volt AC system through power conversion devices. With an engine or APU running and external power selected off, the main 235-volt AC buses energize the 115-volt AC system through power conversion devices. If forward external power is then selected on, the 115-volt AC system is energized directly from external power. The 28-volt DC system uses multiple 28-volt DC buses to distribute power. The 28-volt DC buses consist of primary power system buses located in the forward E&E bay, and RPDUs located throughout the airplane. The higher amperage loads are distributed directly by the bus system. The lower amperage loads are distributed by the RPDUs. The system receives power from the 235-volt AC system through power conversion devices. The primary users of the 28-volt DC system are 4 electrical brake power supply units, which regulate power for the airplane electric brake system. Each of the 4 power supplies receives power through 2 separate 28-volt DC inputs. One input is supplied by the 28-volt DC bus system, which is the primary power source. The second input is supplied by the main battery, which is the backup power source. The airplane's use of variable frequency power requires large motor loads to be energized by motor controllers. A dedicated large motor power distribution system in the aft E&E bay power panels energizes the motor controllers. Normally, the large motor power system is energized by the main 235-volt AC distribution system through power conversion devices. However, portions of the large motor power system can be energized by the APU battery and aft external power through power conversion devices. The APU battery energizes the motor controller required to perform an APU battery start. The aft external power system energizes the motor controller required to perform a right engine start when external power is the sole power source. The Power Electronics Cooling System, or PECS, dissipates heat created by these high-voltage motor controllers. PECS is energized when an engine is running, the APU is running, or the forward external power is connected and selected on. The 787 uses electronic controllers to selectively energize individual loads on different buses. This allows the aircraft to operate a group of loads together as an electrical operating mode. The following operating modes energize high-priority equipment required for the type of operation being conducted. The equipment lists are intended to be a general guideline. They are not all-inclusive. Selecting the towing power switch to on while the main battery switch is off will activate the towing power mode. The main and APU batteries energize only the equipment essential for towing operations. The equipment energized by this mode includes selecting the battery switch to on while the airplane is on the ground and there are no other power sources connected activates the on-ground battery-only mode. This mode is used to support the airplane power-up sequence. The equipment energized by this mode includes connecting the first forward external power receptacle while no other power sources are connected activates ground handling mode. The equipment energized by this mode includes the following. Ground service mode is active when the ground service switch, located on the master attendant switch panel at door 2 left, is selected on while in ground handling mode. In addition to the items energized by ground handling mode, other equipment energized by this mode includes the following. When at least one forward external power receptacle is connected and selected on, while the APU and engine generators are off, activates the external power on mode. The equipment energized by this mode includes the following. Additional equipment that is energized by this mode with 2 forward external power sources connected and selected on includes the following. The loss of electrical power to the captain and first officer's flight instruments while in flight activates in-air RAT-only mode. When electrical power is lost, the main battery is used to provide standby power until RAT deployment. In this mode, the RAT is used to power the captain's flight instruments and other essential equipment for flight controls, navigation, and communication. The equipment energized by this mode includes the following. The 787 electrical system dynamically manages electrical loads. Using electronic controllers, the system can automatically cycle loads on or off for efficient use of available airplane power. The Bus Power Control Unit, or BPCU, provides flight deck control and indication, power transfer functions, and overall load management and protection. In the event of a BPCU failure, a second BPCU assumes all functions. Certain electrical loads are automatically inhibited at predefined operational phases. This occurs when the affected system is not required, or additional power is temporarily needed by another system. This is defined as load inhibit. For example, wing anti-ice, if operating, is inhibited during gear retraction. Loads are also automatically shed in order of priority to stay within the capacity of the available power sources. When loads are shed, the electrical synoptic shows a list of airplane systems affected by load shedding. The affected system synoptic will also indicate equipment that is inhibited or shed. Additionally, loads that are shed show Load Shed text next to the affected equipment symbol. Electrical power to some non-essential loads can be controlled from the flight deck overhead electrical panel. 2 switches are provided for de-energizing these loads if necessary. The In-Flight Entertainment Passenger Seats switch controls the In-Flight Entertainment, or IFE system, passenger seat systems, video surveillance cameras, and flight deck personal electronic device power outlets. The cabin utility switch controls galleys, most cabin lights, and other non-essential cabin utility loads. The Circuit Breaker Indication and Control, or CBIC, provides indications only for thermal circuit breakers, or TCBs, and indications and controls for electronic circuit breakers, or ECBs. The CBIC can be viewed on any MFD. CBIC is displayed on the multifunction display by pushing the System's display switch on the Display Select panel, then selecting the circuit breaker key. The CBIC is operated using a cursor control device and multifunction keypad. Circuit breaker operational status is depicted with the following symbols. The CBIC menu keys at the top of the display can be used to sort the circuit breaker list into the following categories. Circuit breakers can be opened or closed using the CBIC. The CBIC can be used on the ground and in flight. Even though the CBIC can be used, it is not recommended unless directed by a non-normal checklist.